with three fantastic speakers, and an additional announcement at the beginning from Danielle as well. So with it'll be our usual format with three separate speakers. We'll hold our speaker Q&A until after each of the speaker presentations, and then we'll take it to our closed peer sharing discussion for the last 35 minutes of the meeting. All right, we can move on to the next slide there, Robert. And Danielle, I'll pass it over to you for the announcement at the beginning.
Sure. Thank you, Commissioner Paratic. Great to see everybody. We just wanted to flag for everyone in the EV working group that DOE and the national labs are making a fantastic opportunity available to you all, and electric vehicles can be part of what is available. So there are some really robust technical assistance opportunities right now. You can get kind of call the help desk and get some on-demand assistance if you need it from any of the national labs. There's also an opportunity for up to 80 hours of personal support from, oh, go back one, Robert, from the national labs if you have a more intensive question, but that's also on demand. And then right now, this is not quite up to date. Right now through December 31st, there's an application period open for what's called deep dive technical assistance. So this can be actually doing detailed modeling or helping to facilitate stakeholder workshops or helping commission staff review and provide expert comments on testimony that's been filed at the commission. Any number of different kinds of things that you might want help with that you don't have the bandwidth, the expertise, the staffing for. Now is a fantastic time to make requests to this program for technical assistance. And I'm putting the link in the chat so you can find all of this information on the website. And now you can go to the next slide, Robert. There are also some opportunities to talk with National Lab experts about any ideas. So if you're not sure if what you need is something that would qualify as, deep dive technical assistance or help desk technical assistance, you can sign up for an office hours calendar appointment and have a quick chat with somebody at one of the labs who's part of this technical assistance program and get some feedback on your request and your idea to help guide how you proceed and whether it's a good fit. You can also just email me directly and I will be happy to help you sort that out or get some feedback from our lab contacts for you and pass it on back your way. So just wanted to promo that. Everything that we talk about here in the EV working group is fair game. So I hope some folks will take advantage of the opportunity. With that, back to you, Commissioner Paratic, for today's session.
Thanks, Danielle. Yeah, it's a really great program. We've used it at the Michigan Public Service Commission a couple times. The one that I was closely involved with was a technical assistance opportunity that we used for modeling energy storage in our IRPs. So we asked for some help with being able to accurately model energy storage, and worked with our team and also with our with some of our utility partners as well. So it was a really valuable and really in-depth. We did the deep dive one, a really in-depth response from the national labs. Okay, so today we're talking about innovative charging solutions. This is a topic that we've gotten a lot of requests for. Some of the more cutting edge things that are being invented right now. That's one of the fun parts about this space of electric vehicles, is that there's always a lot of new ideas, a lot of new technologies, a lot of new business models, a lot of new methods for actually integrating electric vehicles and being able to use them effectively, use them efficiently, and make sure that we're accurately planning for their deployment into the future. So we'll be talking a bit about some of these innovations today. We have three speakers with us, one from the Joint Office of Energy and Transportation, that's Debs Schrimmer, and then we have Stefan Tongur from Electreon, which is an innovative inductive charging pilot that's just a couple miles from my house here in Michigan. I'm really, really excited to be able to hear some more about the developments there after they commissioned the first roadway here in Michigan about 6 months ago. And then we have Dean Spacht from EVSE LLC, who will be talking about curbside and light pole charging. But we will get kicked off with Debs. I will just give a quick bio for her and then kick it over for her presentation. Debs is the Senior Advisor for Community and Urban Charging, and previously she was a director at Lyft, where she oversaw policy research and development for the company's micromobility division, partnered with cities on innovative street design and curb management strategies, and established the first rideshare partnerships with transit agencies in the country. And now she'll be talking about some additional innovative charging solutions and a Bring Your Own Cord, BYOC, program as well. So Debs, I'll turn it over to you.
Great. Thank you so much. Really delighted to be here today. Thank you for having me. If we could go to the next slide, please. Great. I believe many of you are familiar with the Joint Office. Many of my colleagues have presented at this group before, but just a reminder that we are sort of a startup within the federal government. Actually, our third birthday is coming up soon. We came out of the bipartisan infrastructure law, and we sit between both the Department of Energy and the Department of Transportation. And we're quite focused on the electrification of the transportation network, supporting the build out of a national EV charging network, and really working towards a future where everyone can ride and drive electric. Next slide, please. So our office helps support over $19 billion in funding for clean transportation. I'm sure you all are quite familiar with many of the programs listed here, in particular the NEVI, National EV Infrastructure Program, as well as the discretionary program from Federal Highways, the Charging and Fueling Infrastructure Program. But I did want to highlight two programs sort of listed at the bottom of this slide that are actually funding programs that the Joint Office manages directly. These are really relevant to our conversation today on innovative charging solutions. So one of those is the Joint Office Ride and Drive Funding Opportunity. This is a little over $46 million that we awarded earlier this year, supporting a couple of key topics around resiliency and supporting resiliency in the charging network during extreme weather events and natural disasters, performance of the charging network, and enhancing equitable access. We also currently are running the Communities Taking Charge funding program, and this is $54 million looking to expand community e-mobility options and charging access, electrifying micro, light, and medium duty fleets, addressing barriers to no home charging, and going deeper on managed charging. The Joint Office is really here to help support the deployment of charging stations and use our funding to help sort of catalyze investments in emerging innovative solutions, and some of those I'm excited to talk about today. So if we could go to the next slide, please, that'd be great. So I want to start our conversation with a trip that I had the opportunity to represent the Joint Office on with some of my colleagues earlier this year. We went to Europe. In particular, we went to London, Paris, and Amsterdam to really see the future of urban charging. Europe's about 5 years ahead of us on some of these key topics, and have sort of EV adoption rates that are further along than the national EV adoption rate here in the US, and have really invested quite heavily in charging stations in their urban environments. In particular, this was an area of interest to us because, in the United States, about a third of all US households are multifamily housing. And this is things like condos, townhomes, apartments, residences that really lack the ability to charge at home or have dedicated access to off-street parking. So we really wanted to learn about how Europe was approaching this. They have sort of similar land use and transportation considerations in some of their cities that we face here in our densest cities in the country. And curbside charging was a really prevalent type of charging that we saw across all those cities. And one of the things that really stood out to us as we more closely studied curbside charging was we noticed that when chargers weren't being used, they didn't have a permanently attached connector. And we actually saw that when drivers came up to use curbside charging, folks would essentially open up the trunk of their car, pull out a level 2 cord that they already had, and then attach it to the connector and their vehicle and charge. So this was really novel to us, and we sort of learned that this bring your own cord approach to curbside charging is really popular and sort of the de facto in Europe, and we wanted to learn more about that. If we could go to the next slide. This trip ended up shaping a white paper that our office put out earlier this year on sort of emerging multifamily curbside and multimodal practices broadly. A lot of really interesting implementations of ways to provide charging in an urban context. You'll see a lot of different topics are covered in this paper, but bring your own cord is one of those. And that's the one I'm going to talk specifically about today, but definitely want to encourage folks to check out this white paper. There's a lot of innovative ways to think about providing charging access, and bring your own cord is just one of those. I'm excited for my other speakers on this panel to address other innovative charging topics. Next slide, please. So bring your own cord. I specifically want to explain kind of, what it is. It is also referred to as a carry-along cord, a detachable cord, or a consumer cord. And it's exactly as what we saw in Europe. Essentially, the driver provides their own charging cord and connects their EV to a powered outlet. And this is really for level 2 charging. And in Europe, that's up to 22 kilowatts, not quite generally as high here in the US. But this is really different than how we think about charging here in the US. Notably, in Europe, OEMs provide a level 2 cord at point of sale. And so, from a scaling perspective, it's quite easy for folks to have access to a cord that they can then keep in their trunk and plug in when they need to charge. And it's sort of culturally already sort of embedded into how drivers expect to charge in Europe, which again is quite different than here in the United States. We see, I'll stay on that slide, please. We see 3 key benefits for this bring your own cord approach. One is from a reliability perspective, having less hardware living out on the street means things are less likely to get vandalized or stolen. And if you keep your cord in your car, it's always ready for you to use when you need to use it. Also, there's a lot of benefits from an accessibility point of view. There's less conflicts at the curb with cords not getting put back properly and laying in the street or causing conflicts in bike lanes with other users of the street. And then going back to those theft and vandalism issues, bring your own cord can help support decreased operations and maintenance costs because less things are getting broken or stolen and need to be replaced. Next slide, please. So this is a pretty nascent charging phenomenon here in the United States. There's just a couple of small implementations happening around it, but it is an area of interest for the Joint Office. And I wanted to highlight that earlier this year, we supported funding for a company called It's Electric. They received $1.5 million through our Ride and Drive program to pilot Bring Your Own Cord charging. So they will be deploying 60 chargers in just as 40 neighborhoods across 4 cities in the US. And their project will also be training residents on how to maintain the chargers. And then they'll be creating a curbside charging toolkit for cities. And we've had a lot of interest from cities via our Joint Office technical assistants come in about Bring Your Own Cords. So This pilot program will be really instrumental in helping us understand how users like it, how the chargers perform in the built environment, a lot of really important considerations as cities think about this. Next slide, please. So just a couple of things that I wanted to highlight about the It's Electric business and operating model in particular. So of course, kind of foundational to the bring your own cord charging model, the cable is detachable. The chargers themselves are also quite streamlined and have sort of like a minimalist design just to really have a smaller footprint in the public right-of-way. And then sort of unique to It's Electric's model for bring your own cord charging, they are really trying to promote lower construction costs through shallow trenching from the building to the curb. They are leveraging power from existing residential and commercial buildings to bring power to the curb. And so they think there's sort of a couple of really interesting benefits to that around the lower capital costs and investments required to put in charging. But also there's a potential, for revenue sharing between the property owners as they, make their site an eligible site host to put a charging station. So that can also be really helpful as cities are thinking about where to site the charging. They can sort of entice building owners with extra capacity to site chargers near their property. And, it's a benefit for the cities because It's Electric doesn't have any hardware installation costs that cities are required to provide the upfront cost for. Next slide, please. I also wanted to highlight another example of where bring your own cord charging has been happening. This is in New York City. The DOT Studio pilot program worked with two other bring your own cord operators. One is called Chargy and the other is called Connected Curb. So this was another way for cities to start exploring the potential of bring your own cord. The Chargy bring your own cord model sort of combines their technology with lamppost charging as well. So you see sort of a combination of innovative curbside charging approaches, but this is a really interesting pilot program. And if you want to read a case study on what they learned, I've included the link to that as well on the slide. Next slide, please. So I want to talk about a couple of considerations for scaling bring your own cord in the United States. As I mentioned, it's kind of the de facto in Europe, but it's a very nascent charging model here in the US. And there's a couple of key things to think about as we have more pilot programs and learn whether or not this is conducive in the United States and whether drivers like it. And one of those is a very real regulatory barrier. According to the minimum standards, CFR 680, and these are minimum requirements that the federal government has created that govern the funding programs like NEVI and CFI. They explicitly state in their requirements that each AC level 2 charging port must have a permanently attached J1772 connector. So this is a big barrier for bring your own cord because of course they don't have a permanently attached connector. So a rulemaking would be required to update those minimum requirements to make bring your own cord eligible. And that means right now for the NEVI program, as states reach fully built out and want to move towards potentially using additional funding for community charging, bring your own cord deployments are not eligible. And similarly on the CFI side, bring your own cord charging is not eligible. An operational consideration that I also wanted to highlight was in Europe, when you buy an electric vehicle, it does come with a level 2 cord. That is not the case here in the United States. So needing to think through sort of a scalable strategy for distributing charging cables would be important. Are network operators responsible for that? Could automakers in the US be interested in including L2 cords at the point of sale? or would consumers be responsible for buying them? And depending on, which of those pathways or all of the above get pursued, a lot of operational considerations would need to go into effect to make that work. And then finally, from a technology and standards perspective, I want to talk briefly about J3400 and J3068. If we could go to the next slide. There's, from a technology perspective, some barriers to, really being able to scale, bring your own cord. First, I want to talk about J3400, the connector. This is sort of an important connector to use for bring your own cord. It helps address some of the transformer costs associated with charging and allows for potential for three-phase power. And the industry is moving in this direction. So right now, as we look at the minimum requirements, J3400 is not included in that, though there is flexibility for states to use that. So that would be something we would need to address. And similarly, J3068 is an emerging standard looking at creating a universal infrastructure socket outlet. This would be a really important connector for bring your own cord charging, because it would create one universal socket that then different connectors would be able to plug into to provide power, and that would enable an individual to use, a J3400 connector, CCS 1772, and use that to charge the vehicle. So definitely a lot to think about from like the regulatory and technology and standards considerations, but this is an area of interest to the Joint Office, and we'll continue to follow this and share our findings through our pilot program that we're supporting. Thank you.
Thanks, Debs. Really looking forward to hearing how that all turns out, and definitely have some questions for you along the way, but I will hold those questions until after our next two panelists. And if anybody has questions along the way as well, feel free to put them into the chat, and we can either answer them in the chat in real time, our panelists can, or we can just hold on to those for the Q&A if you don't want to forget them. But we have two more presentations. Next one is from Electreon. So we have Stefan Tongur here with us. Apologies if that is not your name pronunciation. Stefan has led Electreon's U.S. business development efforts for the past 3 years and has been with the company for 6 years. He holds a PhD in industrial engineering and management from the Royal Institute of Technology in Sweden, where he began researching electric road systems and related business models in 2010. And he is here to tell us a bit about the inductive charging road that they've been developing. So I'm going to pass it on to Stefan.
Thanks, Catherine, and thanks for having me. It's an honor and a pleasure. I was looking at your statement, and it said something about, and sorry, because I'm the European guy here, so I'm like looking at all, but it says something about the commission to regulate the utilities that provide essential services such as energy, telecommunication, power, water, transportation, and has largely shaped the profile and substance of public utility regulation in America. That feels like super important, and I congratulate you all for having that kind of responsibility and helping us shape this market as new innovations come to the ground. Because bringing innovation in an area like, bringing EVs, it's both transportation, it's energy, it's data, it's a lot of different things, right? And if you can move on one slide. One thing that I was really thinking about when I did my PhD was how have transitions before happened, and what kind of facilitates innovation and change. And I always come back to this picture, both the horse carriage and that picture, but also this one where you had the oil crisis in the 70s, and we saw the vulnerability of the current system. And I come back a little bit to this when we think about EVs. Are we kind of designing EVs in a manner that is scalable and that is resilient, and where that is kind of user-centric? And I think it is a little bit challenging today because the vehicles with battery need to stop for so long. And I was talking with the Pennsylvania Turnpike the other day, compared to a regular day where they have 500,000 vehicles driving on the road, in a holiday, it's 3.5 million. So how do we do when everybody's going on holiday and everybody has an EV, or let's say 50% of those? How do you actually make sure they have the energy that they need? And our current model is basically let's plug them in and bring all the energy in a battery. So can we rethink that? And to rethink that, you need to go very close to where Catherine lives. If you can move one slide, because that's where we actually brought the alternative here to the US. Please move one slide. No. I was going to do
Like
the drums here.
Looks like we're having some technical difficulties. I'm sure Robert will get it back.
Yeah, so this is actually where we installed the nation's first wireless electric road system here at Michigan Central, close where to West, oh, the name escaped me, but close to the first mile of paved concrete road.
Woodward Ave. Yeah,
Woodward
Ave. First mile of paved concrete road and also the first stoplight.
Exactly. And now we're adding the first electric road here. And it's really, this is really a collaborative effort when you do these kind of innovations. So it's not about Electreon as the tech provider, but it's more partnership with Michigan DOT, with the city of Detroit, with Ford, Michigan Central, and a lot of different stakeholders in bringing this into an area where people can see, oh, this innovation is already here. You can charge vehicles in a different way. And if we can move on, one slide. And the different way is by charging the vehicles wirelessly. So Electreon has deployed in various countries already. So I came from Sweden, where I managed our activities there, in Israel, Germany, France, Italy, and etc., and different use cases. But our flagship project is in Michigan. We also have a project in Utah. And recently we won a project here in LA, where I am right now, with UCLA ahead of the Olympics. So if we move forward one. And just from a technical point of view, you already saw that coil. That coil we deploy underneath the road. You have, and really what we're trying to do is roads are there, and you always redo roads. I think we've all experienced that from time to time. If it's every 3 years or 5 years, we go down about 4 inches when you maintain that road. Lay down those coils. Each one is individually then controlled through a cable. And connected to what we call a management unit, which you see here next to the road on 1 or 2, could be under the ground the road as well. And then you cover that road back with asphalt. So on the road, if you come to 14th Street at Michigan Central Station now, you won't see the actual infrastructure. Everything is kind of covered up. And then you have underneath the vehicle, you have a secondary coil, which we call a receiver. And so when you approach the infrastructure and the road, the infrastructure would know and detect who you are, and then validate that you have a subscription and allow you to get a charge wirelessly, either while you're standing still or while you're driving. And as you pass that single coil, then that goes passive, and then the next one goes active, and then the next one passes. So it's a very smart system. Everything is orchestrated in a real-time, software management, and this system allows you to charge different types of vehicles. It could be light-duty vehicles or heavy-duty vehicles, but also different charging modes. If it's in motion, slow driving at the stoplight, or while driving or stopping still. Next, please. So what is the benefit of doing this kind of innovation? Well, for one, it's really bringing more of instead of having a plug to vehicle approach, you're breaking that. So now we're not stopping at that gas station or that charging station, everybody in a queuing line. Instead, we have a common platform that charges all the vehicles simultaneously while they're driving on the road. And I think from a bigger perspective, or from a larger commercial perspective, a lot of fleets are challenged by moving to EVs because they need to buy so many more vehicles to do the same duty cycle as diesel or gas. So having eliminating range anxiety or charging infrastructure anxiety is a really big thing to allow vehicles just drive as they go without needing to stop and charge. And so I think one of the biggest benefit of that would be on the grid side. So think about it, if we have all those vehicles stopping at a single point and they all charge, and it could be during the night, or if we have megawatt charging and everybody's charging at the same point, you need huge amount of load, and that creates a lot of pressure on the grid. And so if we can charge the vehicles more frequently throughout the day, what will happen is we can distribute that load. You still have the same amount of kilowatt hours, but you can distribute the load and shave those peaks to charge the vehicles more distributed, both over time throughout the day or night, but also during over space. And that will make the transition happen much quicker and much more cost effective, I would say. And the cost can be also shared between all these users that will use this infrastructure. So this allows us to really, in the end, also minimize or reduce sizes of batteries, because those are a big component today in EVs, like a barrier for scale, both on cost, but also sustainability, and ultimately having a more sustainable system where charging just happens in the background and we can focus on mobility. Next, please. So this is the Michigan project. As I said, it's really been an important feature for both us and the state of Michigan. We have a 5-year agreement with the state of Michigan and Michigan DOT to kind of look at the not only technology, but what are the regulatory, what are the business models here to scale this, what are the use cases, what are the OEMs we want to work with. And I find this ecosystem perspective really important here when we bring these kind of cross-functional between vehicle and road infrastructure and energy stakeholders together and figure things out together. So I think that's been a really, really good success of a partnership between all these stakeholders. Next, please. And there's also a lot, I know you guys are spread out over different states, but there is a lot of interest on and have been about wireless charging and electric road system in motion charging. So we see this coming up. I think with Michigan taking this, big lead, there's others. Utah is also very early, but now we have got, California approving our project now with UCLA and funding a big amount there. We have New York coming up, Pennsylvania have a tender out, and this is coming up more and more at different states. So happy to work with you guys and share our knowledge of, what is good programs or how we design these types of innovation, which is really again, collaboration is important for success. So if you go move forward one more. This is, I think, my last slide, where I really want to emphasize on the variety. If I would ask all of you what kind of thought you have, probably I'll get like different types of use cases and uses and vehicles and stuff this could work with. And I think that is the big benefit, that we don't need to start with, let's build 100 miles of electric roads. We can start with smart, efficient use cases where there is a need. We just closed a partnership with UPS and last mile delivery together with the state of Michigan, who's funding that project as well. So thinking about last mile delivery, thinking about university, shuttles, taxis, BRTs, there's just a lot of different use cases where just changing the charging paradigm or charging infrastructure would enable these users to go to EVs in a much more cost-effective way, and sometimes, even easier compared to diesel and gasoline. So with that said, happy to, there's a lot of different challenges and barriers that need to go out of the way. And I think the easiest way of doing that is by showing, how we do it, that it works. And I invite you all to come to Detroit, come to Michigan and engage in a discussion how we can bring this to your state and what kind of challenges need to be unlocked and opportunities that can bring to the future. So thank you so much.
Yeah, thanks so much for the presentation. One opportunity, if anybody wants to actually come see this inductive charging roadway, is that NARUC is actually bringing a integrated distribution system planning and electrification training to Detroit. This is in March of 2025, in a couple of months from now. And one of the plans is to add on a site visit to Michigan Central and to be able to actually see this inductive charging pilot. So it's pretty cool. It's right next to the train station, which was in the background, that big building with all of the lights on in the background of the picture that was in the PowerPoint presentation, which has quite a fun story. It was abandoned for many decades, and then Ford bought it and has built it up into a fairly mobility-centric, innovative hub for a lot of new mobility companies and new ideas. And it's a really fantastic opportunity to be able to see both the Michigan Central as well as the inductive charging pilot. Okay, so we will move on to our third and final presentation, and then we'll be able to get to our Q&A for all of our speakers. Our final presentation is from Dean Spacht, and he'll be talking about the lamp post and utility pole charging. Dean is the Executive Director of Sales for EVSE, which is a division of Control Module, Inc. And while having nearly a decade of engineering experience in advanced aircraft development with Grumman Aerospace and Space Telescope with Perkin-Elmer, the last 40 years have been spent in the sale of technical products such as lasers, optics, industrial scanners, and power supplies, and now focusing for the last 14 years of his career on level 2 charging stations and supporting technologies for EVSE. And Dean has the only patented and truly retractable cable technology on the market. So we will take our next 10 minutes to hear from Dean. Dean, I'll turn it over to you.
Thank you very much. I appreciate it. Thanks, Catherine. As I mentioned, I will be speaking about light and utility pole mounting of EVSEs for curbside charging. I'm going to go over the technology very quickly, how they work, our progress to date, some of the benefits of curbside charging and our units in particular with elevated charging, the obstacles to growth, and some recommendations for how things might be streamlined from a regulation point of view. Our chargers use a motorized retractable cable, which is unique to the industry. It's a patented process that we use to push the cable out, making it ADA compliant, and also retracting it back into the housing of the charging station. As you see here, by doing that, we are able to mount these on garage ceilings. We're also able to mount these on lights and utility poles 10 to 12 foot above ground level. And when the cable drops, it drops to a pre-programmed ADA level, which is programmed at installation. We can mount these on lights and utility poles, as I've said. The nice thing about that is that these poles are everywhere at curbside. In talking to utilities in their service areas, they may have, in some of the larger utilities, have as many as 1 million poles of this type available for mounting of charging stations. Next slide. This is an example of what a mounting might look like if it were on a light pole. In most cases where we're talking about non-wood poles, we're mounting these by strapping the unit onto the pole. We have a back plate to which the charging station mounts. That back plate has a power disconnect so that they can be serviced, and the charging station is removed from the back plate while the back plate and mounting structure stay attached to the pole to make it easy to service. And as you see, they will be mounted 10 to 12 foot above ground level, and they'll drop to ADA level. Next slide. Next slide, please.
So we're having some technical difficulties with the slide. Sorry about that.
Sorry about that. I'm trying to get it back up.
I can't speak to this slide.
Robert will have it back up in a second.
Okay.
Sorry about that. PowerPoint closed out for some reason.
No problem.
It's coming back up now.
We should go back and do Stefan's presentation over again. That was a pretty neat presentation.
Robert, let me know if you need me to share. I have it open as well.
Give this just a second. It's almost there. Okay.
That's it right there.
Great.
Yeah.
Excellent. Thank you. Thank you. So this is an example of how we would mount these on wood distribution poles. So the previous had been a light pole, a non-wood pole, and here we're talking about a wood distribution pole. In this case, we have a special mounting bracket, as you see in the lower right-hand corner, that allows for variations in the pole diameter, up and down, pole to pole, etc. And that provides a very firm mounting to the pole with through bolts through the center of the pole, and then a back plate mounted to brackets, as you see here. And then the charger mounts to the back plate. Again, the bracket and the back plate stay mounted to the pole, and the charger can be removed for easy installation. As you see on the left, the power is pulled off the secondary of the pole and is brought down through the weatherhead to a meter offered by the utility, and then up to our back plate where we have a local disconnect and then the charger. Next slide, please. By the way, on these utility poles, they're using typically to provide residences and businesses. So they typically offer the correct voltages and currents for use with charging stations. Now this is how it would work. As you see in the upper left, or the leftmost photo there, we have a dual charger mounted about 12 foot above ground level. The cable is stowed in the charging station inside the housing. You'll see the driver will walk up to a QR code mounted at ground level. You have two QR codes, one for each of the charging stations, one for the left, one for the right. The driver uses the smartphone app provided by the back office network provider, scans the QR code, that then is verified with the back office network to confirm that it's providing either an approved credit card or some other form of authorization that might be usable to authorize the dropping of the cable. The back office notifies the particular charger involved here to drop the cable, and it automatically drops it to ADA level. The driver here is reaching for it, but normally it drops to the pre-programmed ADA level. The driver then grabs the J1772 connector, presses the latch on the connector, and that latch then allows the charger to drive the cable out as she walks out to the vehicle. When she gets to the inlet of the vehicle, she releases the latch, it stops pushing, she plugs it in, session starts. And then when she returns to the vehicle and releases it from the vehicle, it'll automatically retract into that position you see in the leftmost picture there, with it fully stowed in the housing. I might mention that the YouTube link at the bottom of the slide presents a third-party review of our Melrose pilot and the equipment used in the Melrose pilot just outside of Boston with National Grid. It's a very interesting third-party review, done almost like a restaurant review would have been done. Scared us to death when it first came out, but it worked out to be a very nice review, and you'll find that very interesting, I think. Next slide, please. Now, the reasons for curbside charging, why is it useful? Well, as we heard earlier, many areas do not have off-street parking for their residents. It could be that they live in very congested areas, live in multi-family dwellings. Disadvantaged communities could be downtown, beaches and parks, public areas. The lights and utility poles, as I mentioned, provide an abundance of sites for these charging stations to be mounted. The utilities and or municipalities own these poles typically, and they have right-of-way. So that solves one problem right there. Also, the pole's power is already supplied to the pole, avoiding additional infrastructure installation. Also, with these being located at curbside in public view. The public visibility helps stimulate use by the public and residents, as we saw in our national grid pilot. We have also been told by the utilities that many of them feel they just can't meet their electrification goals at the rate they're proceeding project by project, site by site. And they lose ground on a regular basis in meeting their goals. But now here's an approach where the utility may own 1 million poles of this type in their service area. And by using this inventory of poles, they have a mechanism to mount chargers if they choose to and meet their deployment goals. I might mention also that you see the 2 pictures on the top there. Those are 2 of our competitors. They also mount on poles, light poles or utility poles. But as you note, they are at ground level. They also have their cables exposed to potential of vandals cutting them. They're also exposed to the potential of vehicular damage and also to the potential for flooding. Whereas by getting this equipment away from ground level, you avoid all of those potential hazards. Next slide, please. So now, by elevating the equipment, we have all the benefits of using light and utility pole installations, but we also have the ability of getting this equipment away from the hazards, like I mentioned, of vandalism, flooding, and vehicular damage. As a result, we've reduced the life cycle cost due to these mitigated hazards, and it also eliminates pedestrian obstructions and tripping hazards. Next slide. These are the projects we have underway at the moment. We have a dozen projects, pilots going on across the country using light poles, utility poles, or custom poles as the siting for our charging stations. The Bureau of Street Lighting is the largest of these pilots, going on since 2016. We have 350 ports elevated at 10 foot above the ground on light poles across the city in Los Angeles. Then we also have the next largest pilots in Seattle City and Light and Portland GE. And on the East Coast with National Grid, Melrose, and then numerous other pilots across the country. We have between a half a dozen and a dozen additional pilots we're hoping to get started within the next year or so. Next slide, please. Some of the inhibitors to the growth of this technology are initially that there are just many stakeholders involved in getting this done. You have the utility, the municipality, the EVSE manufacturer, the installer, and the back office network, which processes the billing and the data. And a big obstacle to progress, and we're running into it occasionally, is that many utilities do not allow are not allowed by their DPUs to own the charging stations. So while they own the poles, in some cases they cannot own the charging stations. The problems that creates is that the municipalities then need to own the chargers that they mount on the poles owned by the utilities. That then means attachment agreements, and it means potentially municipal liability for any damage that might be done to pole infrastructure. A good example of the delays this kind of creates is that with our national grid pilot in Melrose near Boston, we probably lost 5 to 6 months in trying to work through the attachment agreements and the municipal liability issues for Melrose. Additionally, we run into long planning and regulatory cycles, as you see here, utility planning and vetting of poles, utility and municipal stakeholder buy-in, local municipal regulatory issues, and standards reviews and inspection approvals. Next slide, please. This is an example of what we had to do for National Grid in our Melrose pilot. National Grid and Verizon co-owned the wood distribution poles that we had to attach to. Again, the city of Melrose had to own the charging equipment, which was attached to those poles. Therefore, they had attachment agreements and they had liability issues. We had, of course, ourselves, the EVSE manufacturer, AMP Up as the back office network, Voltrek as the installer. The program took about 2.5 years from initiation to installation. We've now been running for about 3.5 successfully in that cold weather environment in New England. Next slide, please. Now, the project considerations on any of these projects are too numerous to get into detail here. I just mentioned them, but they tend to cause these programs to delay in many cases. They can be done quickly if all the pieces fit together, maybe a couple months, 3 months, 4 months, but 2.5 years is not totally out of the question, as you see with National Grid, due to the regulatory issues and various technical issues you run into. Next slide, please. These are examples of some of the regulatory issues, not to mention rate structure that comes into play, but local ordinances, traffic and parking related issues, overnight parking restrictions, ADA access to curbside charging, electrical codes, utility standards, and mounting. All of these slow the project down. Next slide, please. So I wanted to just get into this briefly in terms of how we might suggest streamlining of the regulations for future growth. The primary intent is to eliminate regulatory inhibitors to progress where the community interest is best served. So you want to just minimize obstacles to progress, especially where we're dealing with these pilots. You want to minimize regulatory impact for these small pilots where we're trying to determine whether a concept will work in a particular community. A good example of this might be where we're talking about the utilities. The utilities, in many cases, as we said, are not allowed to own the charging stations, yet they own the poles. What we want to do is find a situation where the utility can own both the charging stations and the poles so that the municipality does not have the need to fight the attachment agreements and the liability issues. Therefore, I would suggest that maybe consider allowing some slack for small pilots in utilities to attack some of these new technology pilots and issues. Maybe it's a short-term allowance for these ownership situations where the utility owns the chargers, but by doing that, maybe we can get more of these pilots going without the municipalities having to do the heavy lift that they've had to do with National Grid, where they had to handle these attachment agreements for the sake of an early initial assessment about whether a technology applies. And then on the alternate side is that if we're not going to be able to do that with the utilities, then maybe find alternate ways that we can help the municipalities to come up with alternative mounting infrastructure, such as maybe the ability to install new light poles and then pull power from existing utility poles so that there's no attachment agreement and they're working with strictly their own poles and their own charging stations. And maybe there's surrogate pole technologies that could be used, such as solar or other custom pole types. So again, just remove the red tape, remove the obstacles to progress, and help the small technologies and assessments to become viable. Thank you.
Thanks, Dean. Yeah, you certainly hit on a hot topic there with utility ownership of electric vehicle charging infrastructure. So we might get some discussion around that. It's something that we as regulators think about and talk about a lot. So now we'll be able to open it up for questions. So if we could have all three of our speakers come back on camera, or Dean, we've got your picture up there. So and then we'll open it up for questions from the group. So one of the questions in the chat has already been answered. Michelle had the question of, does the vehicle automatically charge when on the electric road, or does the driver have to initiate the charge somehow, with reference to the Electreon project? And the answer was that it takes place automatically, but the driver will have an option to initiate charging or not. Stefan, do you want to expand on that at all, and maybe answer the second part of that question too, of how and when does the driver initiate that?
Sure. So basically, It depends on a little bit the project, but we have the ability to give like a dashboard to the vehicle. So in the same way you are switching your signal or something like that, there's an easy way of saying, hey, I wanted my vehicle should be on for charging, and then the system will take care of everything. I can foresee a scenario in the future where you're driving on the highway and you're home in like 5-10 minutes, and you're thinking, I want to charge at home, and you can see the rate. So you want to say, hey, I don't want to charge, and then the system will be passive. So I think it will be integrated in the app. It is already integrated into a dashboard. So the charging infrastructure we have, you can see everything in real-time data. You can monitor it. You as a fleet operator or as a driver can have a lot of flexibility in doing what is best for you.
Awesome, that makes sense. We have another question for Dean, I think. This is from Al Freeman. For the pole charging, do you have to do a capacity study before installation? And maybe a follow-up question for me for that. What level charging? Like, what's are these level 2 chargers typically that you're installing? If so, what's the kilowatt numbers?
Yeah, these are level 2 chargers. We're typically running at 40 amp output at 240 volts, so we're about 9.6 kW. That's about 33 miles per hour of charge. We'll be moving to 48 amp output current here in the next few months on those. We typically have not gotten involved in any capacity studies. Most of those would be done behind the scenes with the utilities that we work with, because all of these are collaborations between utilities and municipalities and our equipment. So a lot of work is done behind the scenes that we don't get involved in.
Okay, yeah. But presumably the utility did that study as part of the interconnection process.
I would imagine, yes.
Yeah, that makes sense. But if it's 9 kilowatts, that's definitely an easier study to do. So very interesting. Next one from Kevin Krause. When utilities own chargers, how are rates for EV charging at these stations set? Dean, I'm interested in your perspective on that. But also from Debs, this is, I think, maybe a bit of what you talked about too with the curbside charging. I'm curious if that's something that you saw with the exploration that you've done of curbside charging. Who was actually owning those chargers, and then how were those rates set? But maybe Dean, if you go first on that, and then we can have Debs answer after.
In the pilots that we've run, we have not gotten involved. Normally again, we're the equipment manufacturer, so we're removed from some of these decisions, but the rates are being set by the utilities typically, because in most of our pilots, the utilities, these have been municipal utilities and to a large degree, so they're setting their own rates. Maybe those are dictated to them, but we really haven't been involved in setting the rates.
And this is Debs. At least for the joint office pilot program with It's Electric, we haven't launched it yet, and it's just came under contract and pretty early. So I can't speak to specifics of how It's Electric will be setting things up across the 4 cities, but my understanding is that the utilities will not be owning the chargers. It's sort of owned by It's Electric, implemented in partnership with building owners, and sort of using existing rate structures, but I would need to clarify on that and can certainly follow up on that and report back out.
Fantastic, thanks. Anybody else? Please feel free to just come off mute and ask a question to any of our panelists.
Yeah, I'll jump in. Thanks so much. This was really great. Really appreciated all the presentations. Stefan, for Electreon, can you just talk about any infrastructure upgrades that were needed for your technology, and kind of what conversations, if any, you had with the utilities?
Absolutely. So we actually integrated to an existing drop there. It's like a 480 three-phase grid connection, which is readily available everywhere. So we just connected to that pole that was there. From one point, we brought the power to all our 3 cabinets. It's a quarter of a mile roughly that we've installed now on 14th Street. So it's more about planning, making sure, there isn't, I would say, especially in the beginning, in the first one, so we work closely with DTE. It was the utility there. So there is a need to coordinate early on in the process. That's a lesson learned, because this is a little bit different, and we need to tell them how much load. Some things are similar, some things are different, but through meetings and education and kind of a discussion, in the end of the day, and this happened in Sweden and a couple of other places where we installed, is like, okay, this is not that difficult. This is like a regular grid connection. You guys take this and input this to your cabinet, and we solve it. But in the beginning, I would say encouraging communication with the utility, because there are long lead times, is essential to identify what is the most cost-effective way to bring the power. And they were a very good partner in this. And next road is Michigan Avenue, and Catherine knows about that as well. And that's same process there. Starting the discussion early with utilities is very important.
Thank you. It's great.
So, Commissioner Paratek, I had a question, but before that, I maybe answered a previous question, at least from our. Sorry, Stacy, did you have another question? Did I preempt you?
You did not. Go for it.
Oh, sorry about that. Anyway, Puget Sound Energy owns 8 charging stations. That's out in Washington State. It's a regulated utility which we oversee, and they charge at the market rate, 42 cents a kilowatt hour for fast charging, 28 cents for level 2. So just that's our experience, new experience out here as well. But I did have a couple of questions, but one for Stefan right now. How far are we, Stefan, from the next iteration, which is, not just charging on the road, but actually electrified sort of roads, for vehicles? Is that something in the future? Or is that cost prohibitive at this point? I'm just, assuming you could get through all the permitting and all that, is that something that is even foreseeable?
Yeah, I think with this project, what I just showed you was all the permits and everything. We went through regular processes. So that was the main purpose. We've shown that we can integrate it into existing plans without like changing the rules of the game. So this is possible. It does require, especially in the beginning, a little bit of coordination, like the Department of Power and Works, like in Detroit, the city was like, okay, what is an electric road? Like, what are you trying to do? How does these coils look like? What happened like in the future if another utility wants to repair something? What happens with the coils? Like, there are questions that you need to solve in this initial phase. But I would say where we are right now is targeting use cases. Like, it could be transit, it could be trucking companies, it could be rideshare, different use cases, and then focus on doing both stationary charging, where these cars kind of, if it's loading docks or a queuing line, to the port, cross-border traffic, and then focus on the main routes. So that's what we're doing right now. There are already projects in highways. So we have a project in Utah Inland Port. We have a project in France and Germany on the Autobahn, where we're trying to do this on like it's real life. And the projects are also commercial that we have, a couple of them in Germany and Israel. So I would say the technology is here. And now with the UCLA project, that's a whole fleet, and not only one fleet. And that's the benefit, is to bring in other fleets utilizing and sharing the same charging infrastructure. And I think that will be the game changer. Once you have roads or parking spots, and then everybody can use and utilize them, what will happen is the utilization of that charging infrastructure goes up, and the business model improves because you don't have idling time. If you go on this holiday, you only use them a couple of days per week or month, and then it's a very lousy business model. And if we have roads that people drive on them anyhow, you're sharing that kind of cost over a long time, many users, many vehicle types.
So I guess one follow-up too. I mean, in my experience from a previous life, trying to sort of get permits for trenching, for fiber, those sorts of things. I mean, transportation engineers, that road is sacred for those purposes, and they really are concerned about, harming the integrity of the road for driving purposes and stuff. I mean, is that, and you're 4 inches deep as well. I mean, is this, go ahead.
I'm both 4 inches deep and also have a trench for cables, but I would say what we've done is Jacobs is part of the project, AECOM is part of the project, Michigan DOT, we're working with all the, that's part of the planning and design. So you would see, and if there is an issue, let's say there's an issue on this section of road, like a feet or something, we just skip that and not put the coil underneath that. So we do scan underneath. You can check what is underneath the road. How is so that's part of the design process. And I wouldn't say, I would say we started, like a lot of people started with that kind of fear, but then once they understood the technology and how flexible it is, we were able to overcome them and go through the regular permitting process.
Right. Last question for you. Thank you. Seattle Tacoma, I see, looks like have some. Is that you or is that someone else? I saw on your map that
there wasn't. There was an RFI. I think we submitted and inquired information and an RFP. So there's no. It's not one of those secured projects. It's more that information started to come. Interest from there. Yeah, and I met the Seattle. Yeah, there was a Seattle delegation coming also, or a Washington delegation coming.
Excellent. Thank you so very much. Thank you.
Thank you.
So Mike, Catherine, I had another maybe for Debs, real quick question, if I could.
Sure.
Debs, just in Europe, are you, like you were in Amsterdam and in France, in Paris, are these the BYOC, are they interchangeable between countries? Was this a uniform sort of method?
Great question. Yeah. So we saw a lot of kinds of like different kinds of hardware, even within the same countries. For example, when we were in London, we saw London's a very large city, and they had sort of created different zones within different neighborhoods, and some neighborhoods had certain charging providers and hardware, and different neighborhoods had other kinds. But kind of the key piece of making the bring your own cord work is the chargers have like a universal socket outlet, which then lets the individual kind of like plug in different outlets with different kinds of connectors. So I think, in the United States, this could be a really good investment in future-proofing the EV charging network as different connectors kind of change in popularity as we've seen here. So I think that's sort of one important piece of how the connectors work. It's really an outlet, and then the cable has like a plug on one side to plug in to the outlet attached to the charger, and then on the other side the plug for the connector. So that would be really critical to making it work here.
Great, thank you.
Hey, I had a quick question for Dean. This is Peter Bamel, EPA Energy Star program. One of the things that I've been tracking a bit is consumers' responses and consumers' attitude toward our charging network. And you guys were just talking about Europe, where software is harmonized across charging and across charging networks. So for Dean, an idea would be, rather than having one more additional app that someone in Melrose would need for the pole mounted chargers, and then one for Starbucks and one for Best Buy, and exhausting people with too many apps and too many payment systems. Have you looked at the ISO 15118 and building that into your charging network? The sort of plug and charge standard that consumers can use to charge their cars without apps and without logging in.
Yes,
Thanks.
that's something we'll be introducing in our next gen product next year. Yeah, all these are on a roadmap. We're a fairly small company, so everything gets done on kind of our timetable and not on necessarily what industry's timetable is, just because we're such a small company. But we do have it on the roadmap for next year. Yeah, we have
Great.
heard that also, that the apps do become annoying at time, having so many apps. And sometimes there are aggregators too. We're working with one aggregator that does that. Plus there's roaming. So all of those things in combination are hoping to alleviate that.
That's great. Thanks.
Mm-hmm.
Okay, fantastic. Well, thank you so much to all of our presenters and for sticking around and answering all the questions. We got a lot of interest in this topic. I think it's been a really great session for us today. So thank you so much to all three of you for coming and joining us today. With that, we'll go to our closed session. Yes, thanks. So we'll go to our closed session with just the regulators and from the commissioners and commission staff side, along with some friends from the DOE, and switch to our roundtable. So we have a couple questions on the table today, and as always, we can take the time to react to some of the presentations that we just heard, and also chime in on these questions. We have about 17 minutes of discussion time. I'll just read through the questions briefly and then open up the floor. We don't have to take them in order. Take whatever you think is most relevant or most interesting to you. So have utilities